Welcome back, everybody. You're going to be thrilled. Well, maybe a little disappointed too. This video is going to be a real quick one. I mean, I know we love math because math is fun, but this is just a quick video. We are in Chapter 8. We are on the prompt about distance and ticket price, and we're on the back side questions 6 and 7. Okay, let's just take a look at our grid over here. Notice things have changed for us. Our x variable is now fare, the amount of money paid, and our y variable is now distance traveled. Okay, so it's very important when you are reading the AP Stats test that you identify your x variable and your y variable. And also, you see here we have a bunch of information. This is called a computer output. On the AP Stats test, oftentimes when you're doing a linear regression problem, they give you this computer output. The reason for that is, as you know, sometimes it becomes very, cumbersome to type in lots of data into your calculator lists. And what happens if you make a mistake when you're entering the data? Then all your values are wrong. So they give you this computer output, and you're supposed to be able to identify key pieces of information from it and answer the linear regression questions. So here, as you see in the graph, it says y is now our value of distance. And again, it tells you that here, dependent variable is distance. Remember, y is always our dependent variable. Also remember that x always predicts y in statistics and never the other way around. So in this case, our fare, the amount of money we have to spend, predicts how far we can travel. So say we have $500, like how far will we be able to go on $500? That might determine the destination we choose to go to. So let's take a look at our computer output. Clearly, we need our r squared value. So this is a very important value to us. Okay, so our r squared value is 48.2%. I don't know why that dot won't remove itself. Our r squared value is 48.2%. We are not at all interested, and nor will we ever be interested in r squared adjusted. You can just cross that out. Other things that you can cross out and not even look at are these three numbers. We're not interested in them. Our constant is just our y-intercept, b0. That is the number that is added to our linear regression equation. Added or subtracted, it doesn't matter. It's our constant. The coefficient of the fare, the coefficient of x, well, we know the coefficient of x has always been our slope, our b subscript 1. So here's our b0. Maybe I should put it over here. And here's our b1. Okay, so now it becomes very simple to write our equation, right? We just have to look at this chart, and here's our slope, and here's our y-intercept. Wow, that's pretty easy. Oh yeah, we like it when it's easy, right? Okay, so here's the general form of a linear equation in AP Statistics. Our predicted value of y is equal to b0 plus b1 times x. Well, y is distance traveled, so the predicted distance traveled is equal to negative 644.287 plus 6.131 times the fare. And again, I got these numbers right from the computer output. The coefficient of the constant, which is just the constant itself, is negative 644.287, and the coefficient of the variable fare would be the slope of our line. So here is our regression equation. Yeehaw, that was pretty simple. How far does this model suggest you could fly for the fare you estimated in number 5? So let's take a look at number 5. What did we remember from number 5? Well, number 5, the fare that we estimated, number 5, we said, hey, the fare was $255.83. Okay, that was the fare we estimated in question 5 above. So let's plug it in, plug it in. So the predicted distance that we could travel if we had $255.83 to spend would be approximately 924 miles. Notice that's slightly different than the 1,000 miles we got in question number 5. And that's because, unlike an algebra class where you could swap the x and y, in statistics, x predicts y and not the other way around. So make sure you have the linear equation in the proper form. All right, tune in again. Miss Mac's Academy.